Hi, hello, very good morning to all. Hope voice is audible to everyone. In this session, we are going to discuss more about the. If you make dosa, if it is over roasted, even dosa at the base, it shows black coat. And even when you cook the food in a vessel, containers, or utensils, at the base, sometimes you find a black coat. What all this indicates? I'll give one more example. When you burn the paper and very suddenly it will burns and at last it left with black residue. What all this indicates? All this indicates of the utensils and even over roasting of the food results in black. All this indicates that food is having carbon. Any organic substance after burning, if it left with black residue, definitely it indicates it is having carbon content. Components rich in carbon, source of carbon. The simplest molecule of the food is glucose. What is the formula for glucose? The clothes we wear, even the clothes too made up of carbon. The medicine, when we feel sick, we take the assistance of medicines. And that medicine is also made up of carbon. I already quoted example when you burn the paper, after the complete burnt of the paper, the residue and that residue is black and that indicates the papers, books, newspapers, all writing materials is also made up of carbon. And even if you found any organic substance when you burn and if it left with the black residue, that indicates that is having carbon. So when you quote example, we feel like carbon is abundant. It is found in almost organic substances. But when you look in the earth crust, it has got only 0.02% in a form of minerals. It exists in the minerals like carbonates, hydrocarbonates, and petroleum products. But when you consider the atmosphere, in the atmosphere, it is about 0.03%, that too in a form of carbon dioxide. When you see in the nature, it is very less. But if you see in the organic compounds, it is abundant. It is found in almost all organic substances. Today's Gardening Life, thank you for your visit. And I welcome all for this session. And thanks for your thumbs up. Thanks a lot for your visit. Okay. In the nature, carbon is found in many components like food, clothes, medicines, books, and many things. But in the nature, on the earth crust, it is only 0.0%, and in the atmosphere 0.03, that in the form of carbon dioxide. It exists in larger amount like carbon dioxide in the atmosphere. Definitely it results in, yes, global warming. Carbon dioxide, it is one of the carbon form which results in global warming, which affects on the environment. Even though the percentage of carbon dioxide is 3% on the large level, results in global climatic change. It is most essential element oxygen, nitrogen, and mainly abundantly with the hydrogen. It exists in compound state as it has got 4 valence electrons. Carbon has got 4 valence electrons. Carbon is always undergoing covalent bond. What is covalent bond? Okay, Arpita having the problem. She can't hear my voice. And the same problem to others? Not audible? Okay. If there is problem with the audio, I'll go slow. Carbon, which is an essential element found in organic compounds, and usually carbon forms covalent bond with other elements with hydrogen, oxygen, nitrogen, and many more other elements to form covalent bond. Then what is this covalent bond? The bond forms between two elements by sharing the electrons. Right? Carbon form and covalent bond, the bond formed between two elements by sharing electrons. Okay, this about the covalent bond. So, carbon forms covalent bond with hydrogen, oxygen, nitrogen, and many more other elements. But they never form ionic bond. Why they don't form ionic bond? They can't form ionic bond because easily they cannot convert into ions like positive ions or negative ions. Easily they cannot lose the electron or gain the electron. Carbon has 4 valence electrons. Carbon has 4 valent electrons. It could gain 4 electrons from other element, but for the nucleus, what is the atomic number of carbon? It is 6. So, the carbon will have 6 protons and 6 electrons. In the nucleus, there will be 6 protons. And as it has got 4 valence electrons, it has the capacity to lose 4 electrons or to gain 4 electrons. But it has only 6 protons. So, the nucleus may feel very difficult to hold another 4 electrons along with the 4 electrons in outermost orbit. I'll give the concept here. The electronic configuration of carbon is 1s2, 2s2, 2p2. I'll repeat. The electronic configuration of carbon is 1s2, 2s2, 2p2. In the second orbit, 2s2, 2p2. 2 plus 2, that is 4. That means in outermost orbit, it has got 4 valence electrons. And it has capacity to get another 4 electrons. 4 plus 4, 8. To reach octet structure. But in the nucleus, it has got only 6 protons. So it feels very difficult to hold 8 electrons. So always the carbon will undergo covalent bond to share the electrons with other elements, that too monovalent elements. I hope voice is audible now. Is there any problem with audio? Okay, Priyanka. I'll share the screen. I don't know after sharing the screen how much the voice is clear to you all. Screen. And now let me know more properties of the carbon. The carbon is represented with the symbol C. The electronic configuration of the carbon is 1s2, 2s2, 2p2. It forms covalent bond with other elements, mainly monovalent elements. Even it can combine with some other elements like oxygen, nitrogen, which are not monovalent. Carbon combines with oxygen to carbon dioxide released from the automobiles and industries also has a greater negative impact on human body. Carbon monoxide, sudden release of carbon monoxide, it affects human body. It results in effect on decision making of human brain, and thus many accidents occurs when the people are on long drives. It does not dissolve in water or acids, and it is versatile. That is, it can form a very carbon resulting in catenation. I repeat, the carbon bond with another carbon and such a long chain will be formed, and that long chain of carbon is called catenation. These are some of the chemical properties of carbon. The formula is C. The electronic configuration is 1s2, 2s2, 2p2. It combines with oxygen to form carbon dioxide and carbon monoxide. It does not dissolve in water or acids. It has got ability to combine with another carbon, another carbon, another carbon. It can form a very long chain of carbon, and that is known as catenation. Carbon is abundant in nature, even though it is existing on the earth crust is about 0.02%, and in the atmosphere about 0.03% in the form of carbon dioxide, carbonates, bicarbonates, etc. By sharing the elements, each form of various shapes. It can form bond with two or more elements. Undergo many chemical reactions. Among that, the very important chemical reactions are combustion reaction, where burn in presence of heat and light is it. Undergo oxygen combines with to form carbon dioxide, carbon monoxide. It can undergo addition reaction. The carbon, when it exists in unsaturated form, then if more hydrogen is added, then it can uptake hydrogen and can convert into saturated form. I'll explain this concept coming up. Carbon has the capacity to easily undergo substitution reaction. The carbon can undergo covalent bond with other elements like oxygen, hydrogen, nitrogen, phosphorus, and sulfur. Carbon is biochemical compound. It is very essential for living organisms for survival. The unique property of the carbon is it has got exceptional ability to bind with other elements to form covalent bond, and they are highly stable and easily they cannot undergo the changes as they were. In the periodic table with atomic number 6, with symbol C, with electronic configuration 1s2, 2s2, 2p2. It is located between boron and nitrogen. Boron valence is 3, carbon valence is 4, nitrogen valence is 5. Carbon is a stable element. And they exist in different states, like the hardest substance like diamond. Even it can occur as a powder state, amorphous state, and even it can exist as graphite. Now, how hydrogen forms covalent bond? This is the structure of hydrogen molecule. The atomic number of hydrogen is 1, 1s1 electronic configuration. It has got only one electron. So, in order to form a bond, it requires one more electron. So, it combines with another hydrogen, which is a monovalent. So, hydrogen has one electron, another hydrogen has one electron. So, two electrons will be shared to form covalent bond as you see in the image. So, this is the covalent bond of hydrogen molecule. I repeat, in the first row you can see one hydrogen with one electron, another hydrogen. So, share the electrons. In the second row, the two electrons been sharing with hydrogen. to form covalent bond. Any problem with the audio when I share the screen? Any problem with the audio? Can't hear? Okay, this happens when I share the screen, right? Okay, I repeat the concept. Just now, we had a screen share where we learned about the properties of the carbon. The carbon having the symbol C, electronic configuration 1s2, 2s2, 2p2. It has got 4 valence electrons and it undergo a different chemical reactions. In that, very important reactions: combustion, oxidation, addition and substitution reactions. Now to have the problem, can't hear? Now to having the problem? Okay, now audible. When I share the screen, definitely I know you will have the problem with the audio. Now same thing I'm repeating. When I shared the screen, I explained about the chemical properties of the carbon. Very important properties of the carbon. Now I'm repeating same thing. Carbon, very important, it undergo combustion, it undergo oxidation reaction, it undergo addition reaction, it undergo substitution reaction. These chemical reactions are very essential in order to study the carbon and its compounds. One more image where you saw the hydrogen has one electron, another hydrogen has one electron. These are unstable because 1s2 first orbit should have 2 electrons, but here hydrogen has only 1 electron. They are not stable. They undergo chemical reaction to attain hydrogen molecule by forming covalent bond, by sharing the electrons. Okay, now I'll show the image. You just have a look on the image and again I'll explain the concept. Look at the first line. How many electrons are there? 2. So, one oxygen element has 6 valence electrons. It requires another 2. And what about nitrogen? There are 5 valence electrons and it requires 3 to attain stable or to attain octet structure. You just look at this image clearly. Oxygen has 6 nitrogen has 5 electrons. Okay, just now you saw the image of oxygen and nitrogen. How many electrons were in outermost orbit of oxygen? I'm waiting for your reply. How many electrons were there at outermost orbit of oxygen? I'm waiting for your reply. How many electrons were there at oxygen? How many required structure? Yes, it is 6 electrons. Outermost orbit of oxygen has got 6 electrons. Yes, all of you correct. Good answer. Now, how many required to attain octet structure? If how many added to the oxygen, then outermost orbit attain 8 electrons or octet structure. How many should be added? Yeah, Rekha, correct. Now, how many should add to attain octet structure? Yes, Priyanka, it is 2. If we add 2 electrons, yes, all of you correct. If we add 2 electrons, then it attains octet structure. Means it reaches to the stability. So, now each oxygen required 2 electrons to attain octet structure. So, 2 of the elements combine to form oxygen molecule by sharing the 2 electrons. I'll show the image once again. You just have a look. Rich octet structure. In the second image, both the oxygen elements sharing 2 electrons to form octet structure. Thus, oxygen covalent bond. Same way, nitrogen 5 valence electron. It requires another 3 to reach octet structure. The nitrogen combined with another nitrogen element, they share 3 electrons to attain octet structure, and hence here too the bond formed is covalent bond. So, the hydrogen molecule, the oxygen molecule, the nitrogen molecule. When you see clearly, if one electron been shared, then it results in single bond. Hydrogen has single bond. When oxygen share 2 electrons, 2 bonds are formed, hence double bond. Between the nitrogen, 3 electrons been shared, it forms 3 bonds, and between nitrogen we'll always have 3 bonds. Hope this concept is clear to all. Clarified? Then let me know which part to be clarified. If it's clear, we'll go for another concept. Okay, Priyanka. Vismaya. Who is under name Vismaya? Yeah, concept is little bit hard, but I'm going so slow. I hope everybody can have a clearance with these concepts. Okay, Kruti. Okay, ma. Now I'm going to show one of the image where the carbon has 4 valence electrons, right? Now it can combine with 4 elements. Now what kind of elements can combine with carbon right now? The 4 elements. What kind of element should be 4 elements? Whether the element should be monovalent or divalent or trivalent. I'm waiting for your reply. Now I told the carbon has 4 valence electrons. It can combine with 4 elements, 4 other elements. And what kind of elements can combine with carbon 4 at a time? Monovalent, divalent or trivalent? Very simple. Monovalent in the sense only 1 valence electrons. Divalent means 2 valence electrons. Trivalent means 3 valence electrons. I'm waiting for your reply. I'm not getting. Yes, Priyanka, it is monovalent. If the carbon has 4 valence electrons, then automatically it combine with monovalent elements to attain octet structure. Now, carbon has 4, it requires another 4 to reach octet structure. Another 4 in the sense monovalent. Another 4 elements which should have monovalence, easily it can reach octet structure. Yes, all of you answered correctly. They combine with another 4 monovalent element. Now give me one example for monovalent element. Okay, Varsha, correct answer. Now give me one example for monovalent. Kirti, answer is correct. Give me one example. Carbon combined with hydrogen and reaches octet structure. Yes, all of you answering correctly. It is hydrogen. So, this element is called hydrogen methane. This is called methane electrons. And at each valence electrons, one hydrogen combines to form formula is H4, one carbon with 4 hydrogen to form covalent bond by sharing the electrons. So, methane is highly stable because completely filled and attained octet structure, and there is no place to undergo further chemical reaction. So, methane is highly stable compound. Okay. The kinds and the use of methane. Methane is found in biogas. And what is the percentage of methane in biogas? Yeah, when I share the screen, obviously the voice will be having problem. So you saw the picture of methane where the carbon combines with 4 hydrogen elements to form CH4. So methane is a stable as completely it attained the octet structure, and methane is widely used as fuel, and it is a major in biogas. And what is the percentage of methane in biogas? Yes, correct, Priyanka. It is percent for cooking purpose. We studied this in alternate source of energy. The formula for methane is CH4. Now, this is one example how the carbon can combine with 4 elements simultaneously to attain octet structure and to reach stability by forming covalent bonds. And what are the important properties of this covalent bond? In most of the existing compounds, we find covalent bond, but these compounds have low melting point and low boiling point, since the bonds are formed by sharing the electrons and they are not charged particles. Easily they cannot form ions, and hence they got very low melting point, and boiling point. The carbon shows allotrophies. What is this allotropy? Varying physical properties. Very hard. This compound is also formed by carbon. This can be hardest dimensional structures. In the same way, graphite is also formed by hexagonal ray of structure. Okay, now any audio problem? Can't hear? Just now I told the allotrophies of carbon. What is allotrophy of carbon? They show varying physical properties, different physical properties. When you see the diamond structure, it shows three-dimensional. In graphite, it shows hexagonal array. That is C60. C60. The name of C60 is Buchminster fullerens. Buchminster fullerens as 60 carbon in a form of pentagonal structures combined to form a diamond-like appearance, and thus it forms like a football. It gives a football appearance. As the name is given by Buchminster. So all this shows much variations in the physical properties. When it shows more variations in the physical properties, then you can call it as allotropes of carbon. Okay, sorry for the disturbance. Just now I told carbon compounds show allotropy because they show varying physical properties. The diamond hardest, very hard, graphite so smooth, amorphous, a powder like. So carbon can show such variations, and hence they are called allotropes of carbon. Example, diamond, graphite, C60. So each compound shows different physical properties, and hence we can call them as allotropes of carbon. When you see the diamond structure, it looks so hard. It is almost like stone, and the graphite is a good conductor of electricity. But you see, one is it is a good conductor of heat and electricity, but graphite is good conductor of electricity. So, as they show different physical properties, hence they call of C60, Buckminster fullerenes. The carbon to carbon, they continuously form till C60, 60 carbon, and it is in a ring structures to form like a football like appearance. Sometimes even the carbon can form a long chain and sometimes a branched chain. Anyhow, the carbon with another is a long chain, and hence such arrangement of carbon to form a long chain is called catenation. Till now, formed between hydrogen molecule, oxygen molecule, and nitrogen molecule, and how the covalent bond formed in methane, how the combines with to form methane, and allotropy of carbon. When it shows different physical properties, then we can call it as allotropy. And the catenation, where the carbon can form a long chain, and that is called catenation, and the carbon is called tetravalent, that is 4 valence electrons. The carbon will have valence electrons, hence it is called tetravalent. Okay, this is about today's session. In the next session, we are going to discuss about saturated and unsaturated carbon compounds. That we are going to discuss in next coming up class. Now, which chemicals say all reactions by each one chemical equation. Very important chemical reactions of the carbon. Any problem with the audio? I'm not getting any reply. Okay, Priyanka. If there is problem with the network, I can't have any solution for this. Okay, let's saturated carbon compounds in next coming up session. Thank you one and all for this visit, and thank you for your good feedback. Thank you. Sorry, I just okay. The last question on this session Now each one mention the chemical reaction of carbon. Each one only one chemical, very important chemical reactions of the carbon.